There's one problem that is proving to be a real stumper right now on the homework. This is out of the WebAssign homework for week 3. This problem number 19. So this one is stacking up as, we have this given information. So this is going to be a Venn diagram. This Venn diagram is going to represent 100% or 1 is the whole object. We have over this group, 41% check their work email while they're on this cruise. So this circle here is E for email. That's 41%. I'm just going to label it as 41 for now. 29% bring a cell phone. So this is my cell phone, that's 29%. I've not labeled the overlap there. I've got to account for that overlap. I'm coming up here. I'm going to make this circle a little bit more pronounced so I got a little more room there. And 26% bring a laptop. So that's the laptop, that's 26%. There's those first two. I'm going to jump down to this next one here. 51% don't do any of the 3. So that means 51% is this outer area outside of those 3 circles. So we know that what's inside these circles here, this whole area has to add up to 49%. That's important to know. Now let's go back. 23% check both their work email and use a cell phone. So that means this region right here is 23%. Of those who use a laptop, 87% of those who use a laptop also check email. So that's saying of those who use the laptop, of this 29%, 87% also use email. So 29 times 0.87 is, is giving us, I wrote that in wrong. It should be 26 there, not 29. Thank you. 26% you have the laptop. So it should be 87% of that 26%. So 26 times 0.87 gives us, let me write that in right. There we go, 22.6 here. So I'll put that in a slightly different color. This is 22.62%. That is this green spot. 71% of those with a cell phone bring a laptop. So that's saying 71% of the 29 have a laptop. So 29 times 0.71 gives us 20.59. So again, I'll do a different color. This section here is 20.59%. Well, we can see at the heart of all this is this overlapping section here. In the middle here, that is section X. We need to figure out what X is. That X represents, that's the ones that have all 3. They check their email and they have their cell phone and they have a laptop they're using to stay in touch with work. We've got to figure out what X equals. This is not a simple problem. It's a very complex algebraic issue here. What I'm going to do is I'm going to break down each item in its own. So I'm going to start out looking at just those who are checking email. There's 41% that check email. I'm going to call this region here, call this Z, Y, and W. That 41% is region Z, plus this section right here is the 23% minus, is the 23% minus X. So plus 23 minus X. This region down here is the 22.62 minus X. Plus 22.62 minus X. And then, of course, plus the region X here. So plus x. That's going to simplify. 41 equals negative x, and positive x is a negative x, plus z plus 45.62. If I subtract 45.62, I get negative 4.62 equals negative x plus z. So that's going to be an equation that we're going to use in a system of equations. Next, I'm going to move on to looking at just those who have their cell phones with. We know that adds up to 29% total. So that 29% equals region Y here, plus, this is the 23 minus x again, plus, this is the 20.59 minus x, and then of course plus that region x. So as we start to simplify that, we've got the 29 here, negative x, and positive x is a negative x, plus y plus 43.59. So if we subtract that 43.59 from each side, we have a negative 14.59 equals negative x plus y. There's another equation in our system of equations. Next, we're going to look at the region. Where's my eraser? There. Just for the laptops here, that is a total of 26%. That equals the W plus, well, the 20.59 minus x again, plus 22.62 minus x, plus x. So again, if I simplify that, 26 equals minus x, and plus x is minus x, plus w, what is that, 43.21, I believe. If I subtract that 43.21 from both sides, I get a negative 1.721 equals negative x plus w. Write that out a little bit bigger. So there's my third equation. Finally, I want to do the whole thing. The whole works has to add up to 49%. I'll give myself a little more room down here for this. That 49% is going to equal W, Y, and Z. Plus the 20.59 minus x. The minus x means that's all I'm getting is this piece here. Plus 22.62 minus x means that's only going to get this piece, so 22.62 minus x. Plus this up here would be 23 minus x. Again, so I get this piece and not the x. And then, of course, plus that center piece of x. So if I can combine here, 49 equals negative x, and positive x is a negative 2x, plus y, plus z, plus w, plus, now what is that, 66.21? If I subtract the 66.21, we get negative 17.21 equals negative 2x plus y plus z plus w. So what I get here is a system of equations. I'm going to go x, y, z, w. I'm going to put w at the end just because that's how I'm thinking clearly on this one. So x plus y, I'll put in plus 0z plus 0w equals negative 14.59. That's this one right here. I just put in the 0z and 0w to fill the spots. Negative x plus 0y plus 1z plus 0w equals a negative, now what was that one up here? Negative 4.62. At negative x plus 0y plus 0z plus 1w equals a negative 17.21. And finally, this last equation right here, negative 2x plus y plus z plus w, it also equals negative 17.21. This seems like a really ugly system of equations, and it is, it's 4 variables. But if you put it into your graphing calculator, if you go to the matrix menu, second matrix, and you go over to the edit menu, and just select matrix A. When you select matrix A, it's going to ask you to dimension it. This matrix has 4 rows and 5 columns. So it's going to be a 4 by 5 matrix. And you're going to enter these numbers into that matrix. So a negative x would be a negative 1, 1y would be a positive 1, 0 and 0, negative 14.59. Negative x is a negative 1, no y is a 0, 1z, 0w, negative 4.62. Negative 1, 0, 0, 1, negative 17.21, and then negative 2, 1, 1, 1, negative 17.21. So you enter that 4 by 5 matrix, you exit the matrix mode, and then you're going to have to go back in. You're going to do second, matrix, and you go to the math menu, and you scroll down to RREF. That stands for Reduce Row Echelon Form. You hit enter, and on the screen, it'll say RREF, open parentheses. You're going to have to go to the matrix again. You're going to do second, matrix. Then in the names menu, that first column, you're going to select matrix A. So I'll put matrix A in here. Close your parentheses and hit equals, and it will pop up a matrix that's 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. The numbers over here are going to be your solutions. What you're concerned about is the number is at the end of this first column, because that's telling us what x equals. For this example, it's going to be 19.21 that'll be there. What that is saying, that is, x is the probability of E and C and L. So it's 19.21. Actually, that's percent. So it's a probability of 0.1921 is what would go in there. Once you know that, that makes the rest of it a lot easier. For example, part E or part L of that one is asking what is the probability of, it's a little bit neater, of the person having a cell phone, given that we know they check email and have a laptop. To do that probability, we've got to use our conditional probability formula in reverse. Actually, our multiplication rule in reverse. We know that P of A and B is P of A times P of B given A. Well, if I divide both sides of that by P of A, what that tells me, of course, that P of A cancels out the same. P of B given A is equal to P of A and B divided by P of A. That's what we're going to apply here. P of C given E and L is equal to the probability of C and E and L, which is what we just found up above here, divided by the probability of E and L, which we've already found. So the probability of C and E and L, that's what we found right here, 0.1921. The probability of E and L, if I go up here, oops, helps if I don't move all my, there we go. E and L is the 22.62 here, so that's 0.2262. We divide that out, we get 0.8492. That is the probability of C given E and L. Now, WebAssign is algorithmic, so it might change the numbers that you have a little bit, but it is that same basic concept to find those two probabilities. So hopefully that helps out. Please let me know if you have any questions.